All right, this is ECGR 41, 61, 51, 96, lecture 9. This is class presentation. We're going to go over the robots. We're going to split it into two parts, reverse alphabetical order. The first up is... Actually, I think you were first last time, weren't you? Oh man, must be, that's not fair. Hold on, give me a chance to sit down. Now again, remember you're being recorded. Talk loudly and towards the camera.
Alright, well I did the Talon robot. It is a small guided robot designed for military operations. It is the most common robot used in by the military. The way it communicates is through radio frequency communication or fiber optic link. It's got tank treads, so it has the ability to move through sand, water, snow, and even upstairs. So it's good for urban missions or covert forest missions or whatever. It's got 4 cameras, a color camera, black and white, infrared, and night vision. It has an 8.5 battery life. It consists of 2 lead batteries and 1 lithium-ion battery. And there are currently 4 versions of the Talon robot. It comes in an IED OED, which is a bomb disposal type unit, a SOTAL, which is like a spec ops, special operations reconnaissance type thing. The swords, that's like a more of a guard combat type thing where it's equipped with weapons, and a hazmat for chemical spills or any kind of dangerous material cleanup. I'm going to be focusing on 2 specific Talons. One is the IED EOD, which is, or OED, which has a controllable arm so that the user can manipulate wires or cut and stick, all sorts of things. And it's also only 100 pounds, so it's very mobile. And also there's the Swords Talon, which is for more like frontline military use, where it can guard a region or somebody can operate it and attack an enemy, because it's equipped with all sorts of weapons. You can put an M16 on it, M20, M240, M249, even a 50 cal, or a rocket launcher. So it's pretty effective, but as of yet, it hasn't been used. None of the weapons have been fired yet, but it has the possibility or the potential for some pretty good combat, and that is that.
Is this autonomous at any level?
I presume that when you're doing the bomb disposal, it'll have some sort of feedback sensor to prevent from twitches from the controller's hands.
But for this, you're mostly going to be teleoperating it, correct?
Yeah, remote control. Any other questions?
Is that the robot on Law Abiding Citizen?
Is that Robin?
Yeah.
I've never seen it.
Yeah, it is.
Yeah, it is.
Thank you. Next.
This is the Adept AIV, which is the autonomous inboard vehicle, and comes in pretty much 3 basic configurations that are designed to move parts and materials throughout a facility, whether it's mail or manufactured parts. Has a payload of 25 kilograms, and as you can see in the picture, it can take that. It has a robotic arm that can lift up pod and place it onto itself, or they can slide into a tray system, or a user can actually load it by himself. Some of the sensors that it uses, lasers mostly, for range and object avoidance. Also uses sonar for object avoidance, and has a differential drive system. And pretty much how it generates its path is whoever is setting up the robot will connect a joystick to it and drive it around the facility to teach it correct paths that it can use. And then if it comes across an object in that path, it can correct and go back to its path. It also has capability to be autonomously controlled, or a user can tell it to go to a specific station by pressing a button. And here's a short video of it moving around. It's just it's more of a sales video. It's not really showing actually what all it can do. And this video, well, as you can see right there, it's just going up to the conveyor belt and it's loading trays onto it that it takes to another part of the facility. And in these other videos, it's delivering mail or other small objects or mail or whatever to another person. And that's it.
All right. Questions?
Is there a little man inside?
Just like an R2-D2. Right? Yeah.
You know how much it costs?
They don't have any pricing information.
Oh, you didn't contact them and ask?
Too much.
We'll look his email to this.
Okay. Right. You're Jeremiah, right?
Yes.
Okay. Chris. Wesley. Put the wrong name on there, sorry. Well, I got it.
Okay. I'll just...
Alright, I'm going to talk about FedEx ArcMate 120i it's a spray painting robot. It was designed, it's produced and sold by Roboworks. Pretty much it's a very simple robot. Uses 6 degrees of freedom. It has one right here on the bottom which allows it to spin around. And then the next one is the one that goes back and forward. And then the next one goes up and down. And then it has 3 on the head, which allows the gun paint to move around and cover pretty much the whole 360 degrees. Like right here you can see the what they call the work envelope, which this is like the X-axle, so it kind of covers pretty much all 360. And this is like the Y and Z axle, so it covers pretty much like the whole sphere, so it can move any direction you want. The 6 degrees of freedom are electric servo motors. The horizontal reach for the paint is about 1.8 meters. The payload is 20 kilograms of paint. This roller can also be adjusted to do welding, so you can actually load that with solder. And it could be mounted on the floor, ceiling, wall, or if you got angles, it can be mounted on angles too. The controller is an integrated controller. That means that you can program the robots on the body. It seems like back in the day they used to connect cables and stuff to be able to program it. Now you don't need to do that, so it's kind of get rid of the cables and all stuff. Advantages: improves the quality of the product, of the end product, compared with personnel. If you use personnel, you know, it might be a little the codes might be a little uneven. Saves paint, meaning that using the same amount of paint for one unit to the other, it doesn't waste any paint. If you use people, they might use more paint for one unit than the other, so you waste. Safety. Once again, personnel, you had to buy insurance for the employees. You had to protect the gear, buy protective gear. With this kind of robot, you don't need nothing of that. Saves energy, uses state-of-the-art technology to only use energy as needed without any waste. And space, it doesn't need much space to perform, so you can actually put 3, 4 together in a small room, so that saves money and cost for the company. And that'll be it, my presentation.
Question for you. So what connection is there to that unit when it is running?
There's just a power cable.
So it's just power. Is it a cable or is it something
It's a cable, yes.
underneath? So even though it has 360-degree range of motion,
Right, but
it still can't spin around and around and around, right? Because otherwise you'd bind up the power cable. Anything else?
Hi, good afternoon. My name is Benjamin Rhodes. I'm going to talk to you a few minutes about the Bear robot. It was developed by Robotics. Started in 2007, was the development stage of it before they got the funding from outside resources. Bear is actually an acronym for Battlefield Extraction Assist Robot. It's kind of along the same lines as the first thing I was talking about. It's essentially a robot that's semi-autonomous in its current stage. The only thing autonomous it can do is go to a GPS location, much like the dog we talked about, going around with a little sound of weed eater going off. But also, it can also, like say, go to this point, GPS, also go to this box or this material, it'll scan and say, once it finds a object such as a box or a crate, go to that. So that's the only really autonomous part they have right now currently. One interesting thing that drew me to this robot was the type of locomotion that it had. It's pretty unique. It's a track design, but if the algorithm is developed correctly by the end of this year, it's going to actually be able to stand up on the track and be able to balance itself with some of the balancing technology we've discovered in this class in the past couple of weeks. Some of the sensors the robot has is some tactile sensors on the fingers. Originally the design was a scoop design, but now they actually have fingers that actually work to pick up objects. It has 360-degree infrared camera and just a normal optical camera and night vision camera for an actual operator who's controlling it manually. Also, it has 6 degrees of freedom for the fingers. And an interesting thing I figured out for the fingers is actually they've developed, some of the engineers, mechanical engineers, have developed a micro hydraulic system. Now this could be able to make this hand grasp like an egg, for instance, or something very, very delicate and not be able to break it. Before it's just on or off, on or off. You can grip something, but it's no sensitive. So that helps with the tactile sensors and the very sensitive micro hydraulics that are patent pending currently. Right now it's in the proof of concept stage, which we learned through system engineering, is just to give the people in the high authority, hey, this is going to work. Your millions of dollars you've invested in this is going to work. This is what we have this far. So I'm going to go to a video real quick of it actually working. I only spend a few seconds on here, but this is just a proof of concept. There's no audio, so it's okay. But the neat part I like about this video is when actually it drags the human body, it kind of looks like something off a sci-fi movie. It's actually kind of neat. Break through walls. I want the MacGyver theme song to be going on right now. I'm really good at it going, but see, listen to the way it's Listen to the way it's looks poor in my more. It's pretty bad, so. And also, as a kind of funny note, as I always want to do my presentations, supposedly the bear got the idea from having a friendly face, but I'll let you be the judge if that's a friendly face or not if you're one on the battlefield. So
He looks like
that's all I have for the presentation.
Jason.
Yeah.
I'm presenting the HAUV, it's the Hovering Autonomous Underwater Vehicle. It's manufactured by Bluefin Robotics. What it's manufactured for is for surveying, underwater surveying of the ocean floor. This one exclusively surveys the hull of a ship underwater. Some applications are the ship hull infrastructure inspection, unexploded ordnances. It could go underwater and explore for underwater or unexploded ordnances. Also, another application is scientific research, mine countermeasures, and security, underwater security. The energy source is a 1.5 kilowatt-hour lithium-ion battery. Propulsion has five thrusters, which are pretty much fan blades that spin for stability and control underwater. Some sensors, the internal measuring unit for velocity, orientation, gravitational forces. It corrects basically when it's underwater, the tilt and turn each fan blade. The DEL is a Doppler velocity log It's basically underwater GPS. The satellite, satellites for normally GPS can't work underwater, so basically it's an underwater GPS. Depth sensor to obviously track how far below the surface it is. And most importantly, the DIDSON is the dual frequency identification sonar, operates at 1.8 megahertz, and this uses sound waves to map and create the image of the ocean floor or the hull of a ship. It will give a high definition image of what it's surveying. This robot is completely autonomous. There is fiber optic cable attached to it in case the people who are doing the survey spot something, they can override, put it in, take it out of autopilot, and they can control it from the ship or from land. And that's it. Any questions?
I chose a rock, paper, scissors robot. It was developed by researchers at the Sensor Fusion Laboratory in Tokyo, Japan. And it has a 100% success rate when playing rock, paper, scissors with a human. So, it uses a robotic actuator that represents a human hand. Has 3 fingers on it, an actual a wrist joint that will move. That angle of the wrist will actually copy or mock the human's wrist angle when you're going 3, 2, 1, shoot. And this implements a high-speed camera that is programmed to recognize hand shapes. It somewhat cheats in a way because it's looking at your hand and the movement of, like, for instance, if you were to be able to do scissors, it's looking that the 2 fingers are coming out and then making that response within 1 millisecond.
Huh.
So it kind of cheats.
It cheats!
So it's doing it after you do, which is not the rules of the game. You can't do it after the other guy does. But it's so quick that it's instantaneous by the human eye. So you don't really see this. I totally forgot to put the link on YouTube to show you it actually, in action. But it's check it out after class. So why is this relevant? Really shows how like human and robotic interaction can be instantaneous, and the robot actually responds to you in real time. So, any questions? Thanks.
Hello, I'm Alex Monster. I did the Amphibious snake. It is a completely autonomous robot that moves like a snake does over both land and through water. It does this using multiple motors and computers in between each of the links that allows it to make movements for each part individually and on their own, or work in unison with the other parts to be able to make motions across the ground and through water. It has been programmed to do basically follow movements of an actual snake. The only sound that there is in the video is just the sound of the wheel-like implementations on it that they call, I think, fins. They basically are just wheels that are there to help it move across the ground. They're not motorized. You can see the wheel-like. Nice.
The water?
Yeah. Currently currently the only thing it really does at the moment is just explore its environment. But that is the amphibious snake.
Who made it?
I don't remember who made it. I think it's, you can see it there if you read it.
Tokyo Tech, I think it says.
Tokyo says.
My name is Josh Morgan, and I did the Alice micro robot for my project. Some of the main features for this is that it's very small. It's only 2 by 2 by 2 centimeters. The main purpose of designing this robot in the beginning was to design an intelligent robot as cheap and as small as possible, provide a hardware platform for future research, and to study how they react with one another in mass quantity in a large area. It has up to 10 hours of autonomous battery life with 2 motors, one to power each wheel individually. The onboard modules used are a linear camera, which you can see on the top. It's a 102 pixel camera. It has radio communication and tactile sensors on the sides in order to tell what if it bumps into stuff. And I couldn't really find a lot of research on this, but as far as the technology goes, it's mainly just to design a small robot and that functions and interacts with other of the same robot, and to test what it does when it interacts with another one of these robots and gather basically a research. So it's mainly a research project. And that's really all I could come up with on this robot. Are there any questions?
What are its sensors?
It has a linear camera, which is that top thing, and it's a 102 pixel camera, so it can, I guess, interpret images and react to what it sees as far as terrain and other robots go. And it has radio communication for interacting with other robots as well, and tactile sensors for bump sensors and running into things to be able to interpret where it's at as far as its location in respect with other things and objects.
I guess I'm a little bit non-knowledgeable. Linear camera implies that it's 102 pixel by 1 pixel. Is that what that means?
All it said was linear camera, and then it had
Okay.
in parentheses 102 pixel.
Okay.
Are there any other questions? Thank you.
Hi, my name is Jessica Meeks. I did the KUKA, I'm guessing I'm saying that right, KR-1000 Titan. And it's a 6-axis industrial robot, and they say it's the strongest one of this type, as it can pick up to a ton as its payload. It does this by running on 9 motors, which help it do a 6-axis movement. And basically that means it can move around the base. There's 2 joints, and then it's got about 3 more movements towards the end. So you can see it in action. And it's PC-based control, so basically you can either do it manually or you just program it in and it'll run on its own, like it's pretty much doing here. I think it might have a server in the background or something. But here it is, I think at the BMW exposition. So it's moving this car with this stuffed bear in it. As far as sensors go, I'm pretty sure it has some sort of rotary encoder. It was hard to tell, as all the specifications I could find was in like Deutsch and Italian and Spanish, and I don't know any of those languages.
Google Translate.
Yeah. But so I'm sure it has encoders so it can tell exactly the angle it's going at, and then it's going to have some sort of distance at the end so it can make sure it's making connections and lifting things up.
Just passing along.
Oh yeah? It's what?
You can't leave yet. We have questions.
They tell you how much that thing costs?
She says BMW.
You said 6 axis. Is that the same thing as degrees of freedom?
Yeah. Basically, like it's because it can rotate one axis or it can go this way, but it's more of a like planar thing.
Okay. Because you know it says 9 motors, so I guess it's using the extra motors to get additional torque.
Yeah.
Because it's such
Like,
a
a couple of them, you see 2 motors will feed into a single gear, and so that'll just run like one, and then others are going differently.
okay.
Hi, I'll be speaking on Stickybot. Now these are robots which are capable of scaling vertical surfaces. This particular iteration, the third one, it can scale glass surfaces and polished granite. Hopefully the future iterations would be able to scale rougher terrains. Now when we need to scale any vertical surface, there are a few mechanisms that we can employ. One of them being using suction, but then in that particular scenario, there's a lot of energy wastage in actually causing the suction effect. Another mechanism that we can use is using adhesives. That again causes wastage of energy. So then this one makes use of a directional dry adhesion. Here what happens is there are at the feet of the robot, there are these microscopic bristles facing downwards, which attach itself to the wall, and because of gravity it pulls the machine down, and it completely sticks to the wall. So when you want to release it, all you need to do is lift up the arm. We'll be seeing this in motion in the video. Next is it has got 4 degrees of freedom, 16 servo motors, that's 4 motors for each arm, and let's have a look at the video. You can see here, when he needs to release it, pushes it upwards. These are the various degrees of freedom that it provides. And this is how it actually takes place. It's got these microscopic vessels. So we're going to take the load of the entire robot. Any questions?
By the way, we can just keep on going and finish early, or take a break.
Keep on rolling. Keep on rolling.
Finish early.
All right, let's go. Take a break. Raise your hand.
Put your hands down.
And keep going. Raise your hand. All right, we'll keep going.
I'm here tonight. One that you want.
I'll tell you, Ruba, after this, you could take a break. How about that?
What about that quiz? This is the robot fish, which it's just like a fish that operates underwater. It's autonomous and it's battery powered. It's 5 foot long. The fins are constructed using oscillating servo motors. So basically you have the oscillating motors that are attached as cranes to holding flexible membranes that slide and allow the fins to, the length of the fins to be moving. That it has proximity sensors which senses objects without physical contacts to avoid them, and depth and pitch sensors. Those are controlled by microprocessors, and chemical sensors, because the purpose of this could be used for monitoring oxygen in the water level, or could be detecting oil spills from ships or contaminations from pipes that are underwater or any leaks. And the information is transmitted wirelessly to once the robot finish goes to the surface, the information is transmitted to the port of wherever that information is going. And yeah, how did we go?
I don't think that has anything to do with fish.
Those are ads.
Sorry about the commercial.
It's not moving.
That's it basically. And it's that's in London. In aquarium. That's it.
So if the water gets too hot, does it float to the top?
No, it's it actually operates kind of like similar to a fish. The fish has a gas it has a gas bladder, and based on the volume, the fish controls the volume expand, and it would control where the fish wants to be, and there's pistons in it, and that's how it's.
I think they were making a joke first
I
of
know
all.
it was, but I was just like throwing that out there.
Is this commercially available, or is this just in the research lab?
I think it's just for research purposes. There was a grant from the European Union for $3.6 million to do, I think, to test it in the harbor of Jinan. I think that's how it's said. Yeah. Somewhere in Europe. Anything else?
So I did my presentation on Google's driverless car, which is nicknamed Stanley. It's a car that will drive to any location by itself using a mix of Google Maps and the sensors on the car. It's a DARPA-sponsored project that won the Grand Challenge in 2005, I think. So the sensors it uses are some video cameras inside the car and LiDAR on top of the car, which is what's shown in the picture there. And a mix of the radar sensors as well to not run into the vehicles around it, to be able to stay in the lanes and all that good stuff. It uses the GPS, of course, to map out its route, decide where to go and how fast to go. For the movement, they put controls in that utilizes the tires, brakes, the motor, everything that's already on the car, just as if a real person was driving it. And there is if anyone is driving the car manually, then you can sit back and let it drive you, or if you take the wheel and turn it, if you hit the brakes or something, it'll let you take over the car. So it has manual and autonomous selections. They've actually done this on 6 Toyota Priuses, 1 Audi TT, and 1 Lexus RX 450h. The uses for this car would be to decrease the amount of traffic accidents and traffic-related deaths, such as people who on last Tuesday are in a Jeep that flipped over on the side of the road. And it also helps increase efficiency on the roadways, making sure that if it were, for example, to catch on, every car on the road had it, everyone would be the same distance away from each other, driving at the correct speed limit at the certain, space from the other lane. So it'd just be safer, and you use gas more efficiently, you use space more efficiently. So it has a lot of potential, but it's also very expensive. Any questions?
Sorry. I was actually researching this for this one of my robots, but they actually put this on a NASCAR, and Google has a racing team now. It's called Google Racing, and the number on the side of the car is 10 to the 100th, which is another name for Google. Like, that's what Google means.
Yeah.
So I think they did like a joint venture with NASCAR. I think they're going to be like racing it or testing it with the race cars. But it's like, it looks just like that, except the NASCAR is a cool thing.
With this, would you really have to drive the same speed limit if it's autonomous? Because wouldn't that take out human error and allow you to drive faster?
If everyone had it, yes.
I mean, if somebody's in front of you, then it'll use the sensors to stay a certain distance back, which is going to put you all at the same speed anyway.
Yeah, but if
So you can't. It uses the GPS and it takes a speed limit from that to tell how fast to drive it. So you can't really program it to speed and do 100 down the Autobahn or something.
I see it, like my thought was, if everyone got on board with this, the speed limit could increase because human error is removed from the equation.
It could.
And all cars could travel faster on highways and stuff like that.
It could, but I don't see him doing that. The options there. And they actually have driven between the 8 cars that I mentioned earlier. They've driven it over 100,000 miles combined, and there have been no accidents that were from it running on its own. It has, however, been run into by other drivers, and there was one accident in the Google parking lot where someone took over and crashed into something.
All right, I'll step back a minute and say, why is Google doing this?
Because they're going to take over the world.
Now, I mean, in the end, it all comes down to money. Google doesn't do anything unless they see money at the end of the tunnel. Why are they doing this?
The project was first created, and they won a whole bunch of grant money through DARPA, but it was created, the idea was created by a Stanford University professor who was also the co-founder of Google Maps. So I think he just used the Google Maps and said, how can I use this another way? And then mixed DARPA into it to get money involved. I think that's how it came to be.
Okay. Is this where all is Google where all the, like Mercedes and BMW and all that stuff got there?
What?
Like technology?
The parking thing?
No, like if you floor my dad's car straight to the back of another one, it'll slam on its brakes on that.
Oh, well, that's just some sensors that are keeping you at a certain distance.
But I'm saying it won't allow you to turn in the lane next to you. Like it'll lock the wheel, so you can't go next to you if there's a car there. Or it'll say, like, I just leave cruise control on, and then it'll just slam on brakes or speed back up.
They may have just gotten the idea from this car, or they may have come up with it on their own. Not sure.
That DARPA project that I think it was like maybe 2 weeks ago that people had the Volkswagen with like the Red Bull stuff on it. Those were Stanford, and they called it Stanley. And I actually heard that they hired the chief engineer from that project to do this. That's why this one's called Stanley.
So this has absolutely nothing to do with gathering the pictures for Google Maps.
You could use it for that, but the only thing that I found for it was that it was a research project for DARPA.
All right.
And that they are trying to pass Nevada state laws that allow you to get a license for an
It's already done.
car.
It's already passed.
Oh, okay.
In fact, they just did it like 2 weeks ago.
There you go.
How much does an autonomous car cost?
I don't know.
How much do you have?
You just write out a blank check to Google, and they'll fill in the rest for you.
It's kind of already a little bar.
Any other questions?
Yeah. Can they give you the UIs?
You're not driving, I guess.
All right, let's take a quick break.
Hello, my name is Herbert Hill, and I'm going to be presenting the Vanderbilt University bionic leg. I chose this one specifically because I'm interested in biomechanics, and this is what I want to do my graduate work in. This project was basically building a bionic leg. I think it started in about 2009. I listed the major features. It has a computer board, and it's an embedded system. It performs several tasks simultaneously, and it also is based off of microcontrollers like in smartphones. So they use that small technology to fit it inside of the leg. The sensors that it uses, I figured, was accelerometers. They only spoke about two different things that you could do. One was stair ascent, and they said for you to climb stairs, all you had to do was kick your leg back, and then it will automatically go into stair ascent mode. And it also has an anti-stumble routine, so if you trip, it helps you catch yourself. It has two electric motors, one in the knee joint and one in the ankle joint, and the battery can operate for approximately 3 days or 13 to 14 kilometers of continuous walking. The other things about it is about 9 pounds and is currently being worked on as far as noise reduction. The professor that worked on this was Dr. Michael Goldfarb, and the first person to use this was Craig Kudo, who said a passive leg is always a step behind me. The Vanderbilt leg is only a split second behind. So normally a prosthetic leg, they have to swing their leg and just use a lot of their hip muscle to do it. With this, they're able to just walk like normal, and it relieves a lot of stress in the hip. And also, I have the two different versions that they had. The first one kind of looks like a dinosaur leg, and the one on the right looks more like a human leg. The one on the left had hydraulics in it, which also weighed it down, and also the battery and the embedded system were close together. I'm guessing that they separated the two maybe because the battery was overheating and all that electronic stuff together. And also the ankle and knee joint are more independent, and I'm guessing they use stronger motors for that also. And that is the Vanderbilt bionic leg. Any questions?
Hello, my name is Stephen Gong. I'm here today to present the automatic guided forklift. AGV forklifts are being used more commonly in the manufacturing facilities. So the picture here shows a variety of different designs or different forklifts that are out there. If we use system engineering methodology to build and design the forklift, you can break down the forklift into different subsystems. You can have the mechanical, drive and lift, communication software, power and electrical system. The one thing to keep in mind is the control mechanism for this. For the AGV forklift, it can be operated automatically by wire guided or laser guide. And it can also be operated manually by a handheld keypad. And it can be communicated wirelessly by Wi-Fi, AOT network. That's pretty standard. The power and the electrical system for the motor are 48 volt VDC, and for the controls are 24 volt DC, plus my 12 volt and 5 volt DC, depending on the application that you are using it for. And the advantage of the automatic guided forklift is that it's operates more efficiently, and in the long run, it's saving the company a lot of time and resource. So and it's operating much more safer. That's all I have.
No questions? All right, next.
My robot is called 21. It has 47 degrees of freedom. It measures 4.8 feet tall, 2 feet wide. It weighs 250 pounds. It has a omnidirectional wheel-based mechanism for mobility. It has soft skin silicone to prevent elderlies to crash into the robot and get hurt. Also, embedded in the skin, there's pressure sensors in the whole on the whole skin to detect whenever the robot is touching a human or heavy object or just an object, so you can avoid it or handle with more care. The fingers, it has 4 fingers per hand. Each hand has 241 pressure sensors. Each hand also has 13 degrees of freedom. It has 12 ultrasonic sensors. It has 6-axis force sensors to detect objects or humans near it and avoid also collisions. The arm, the shoulder, and the elbow has 7 degrees of freedom, and it can also lift a human weighing around 77 pounds or 35 kilograms. The trunk has 4 degrees of freedom. The head, it has 2 CCD cameras, and the cameras are surrounded by LEDs, so it will tell you when the robot is on, it's on, or it's getting your inputs. It has a speaker, and it has a 6-axis force sensor also in the head, so you can slap it in the head and it will detect if it's being hit just in recognition of something good that it did or something wrong. The head also has a 3 degrees of freedom. It can tilt, roll, or pitch. At the release, it will cost about $100,000 to $220,000. And the purpose of this robot is to help the elderly in Tokyo, Japan. Questions? Oh, thank you.
I'm Scott Collins, and I decided to, are you ready? Okay. I decided to do my robot presentation on Freda, which is made by a company called Adept. The idea behind Freda's initial project was to create a robot that could work in a manufacturing environment, basically in a lot of repetitive manufacturing environment like small scale electronics, where they work long hours, and it could work alongside other humans. So it needed to be it needed to make sure it follows the main rule, I guess law number 1, of not harming other humans. The Freda acronym came from the Friendly Robot for Industrial Dual Arm Assembly. So it's a dual arm robot. Each robot has 7 axes, which is supposedly to mimic the whole human arms and humans working in an environment. It's designed not to replace human workers, but to work alongside. Whether that's true or not, we'll see. It's in concept stages now, has not really been put to work out in manufacturing facilities. The control system itself is located in the torso, you can see down here. And it's powered by single-phase power, so it can pretty much be used in anyone's home or anywhere. It can be moved around manually by a single person. It's clamped to a table and can be programmed relatively easy. It has cameras for object awareness, which can work along with the programming that is done by the whoever places it wherever it has. So supposedly it can do one project, you can pick it up and move it, easily program it to do another project and just based on repetition. All of the robot itself, the gray areas are padded, so in case it bumps into a human, it supposedly won't work them. It won't hurt them. It has software collision detection in order to reduce danger to humans. It also has limited power to the motor, so basically if it bumps into anything, this is made for small scale electronics, it just stops moving. The fingers themselves are servo controlled. It's just a grip basically, and it can go down and pick up very lightweight objects. And it also has a vacuum controlled suction cups on those fingers to help hold on to it. And I believe, if I can figure out how to do it, I have a small video. Oh, can I make a video?
Is that a ball or a balloon?
Clamps to the table, and it's just showing what it's capable of doing. That's it. Are there any questions?
I have a question. How much does it cost, and how many companies use that?
I couldn't find how much it cost. However, I did. It's supposed to be relatively inexpensive. There's a company, I believe, out of Tokyo, Japan, who's
I don't want to watch that video, okay?
Who supposedly ordered 1 million of some sort of robot like this, and they believe it was the Freda robot, not to replace humans, but to work alongside. You know, as far as humans get tired, this thing can work long hours, doesn't have to have insurance, doesn't have to have food, all it needs is power and it's good to go. So, but I couldn't find the price. It's supposed to be economical.
But, I mean, is it actually used right now?
No, as far as I know, I don't believe it's ever been actually put into the workforce.
The answer is no, it's not.
Yeah, Foxconn.
I did a web search and they said no.
Yeah. Foxconn, I think, is debating on ordering $1 million. Is a company in Tokyo.
Foxconn?
I think. I hope.
They want to.
It's a concept, but they're trying to find a use for it, in the real world.
By the way, does anybody know who ABB is?
Power company.
Power company.
Breakers. Stuff like that.
American breakers.
And controls and stuff like that. There's a plant in Huntersville that does cable. Big cable. You might want to check. I don't know if it's only manufacturing or if there's design there, but if you are interested, you should look up because they're actually starting to get a big presence here in Charlotte. They have a big presence over in Raleigh. They're in Centennial Campus with NC State.
What's that that company you did like a News 14 interview about?
Oh, that's the people who bought Goodrich.
TMC or
No,
TMU or
it's the United Technologies. Oh, Pratt and Whitney, I think, right?
Okay. I think they had multiple companies that they
Yeah.
control.
Oh, go ahead.
So, alright, I'm gonna talk about Gumi robot. And alright, this Gumi robot was built by Harvard scientists. Alright, and the inspiration came from squid. And this robot is very different as all the other robots we were talking about, like for past 20 PowerPoints. And it's very flexible, and the length of this robot is only 5 inches for current state, and this is nowhere autonomous at all. So and it has 4 legs, and this device has no hard materials, hard parts, and all the stiffness are coming from air pumping from the tube. And you see this right here? There's 5 tubes, and it pumps into 1, 2, 3, 4, 5 right there, and it moves kind of like just like you know how it just push. This is a rear leg, so it's kind of push it up and kind of like that. Alright, and so And this has a little chamber right here. It's all open, so air just goes in and kind of pushes itself up, and it could move front. All right. And this is like the first rubberized robot, fully rubberized, and was built by Silicon. And right now they're using remote control. And for this robot, for this device right here, it has no power at all. If you want to say there's used some power, it's the device that pumps air into it. All right. And the purpose of this robot, it could, for instance, you could just crawl into the rock or something after an earthquake, find some alive human or something, or dead body. Or, I mean, eventually you could put some sensor at the tip or something. So it kind of sends some thermo or something like that. And yeah, that's about it. And I got a little clue.
Keep having a solve responsibilities.
And froze. I mean, alright. If you guys don't want to watch it, alright, I'm done. I mean, froze. I can't do anything about it. Oh, and Harvard people spent 2 months to develop this.
For 2 months?
2 months. Only 2 months. I mean, gross. I was kind of excited to show you guys how to just crawl.
Try to find the body.
And you can kind of like
Close it.
Alright, so this is the nuclear reactor inspection robot. It was first thought of for after the Fukushima Daiichi nuclear plant exploded. Basically, it's a spherical robot that can go through the pipes and things like that, check on different welds and make sure all the welds and everything are in place. Some of the neat things about it is the things called jet actuators. Basically, it's kind of like airflow in aeronautics. The way they have the air going through the tube can also force it to one direction or the other, so they have it coming out either side, so you can see the left flow or the right flow in that top corner, which is helpful for navigating things like that, basically because of this eccentric mass steering that changes the level of the water, so it needs to go lower or higher to check different welds and things like that. It also keeps it spherical shape because in order to do that any other way, it'd have to have outside actuators and motors and things like that, which could also damage the pipes, which they don't want to do because of the nuclear reactor. So that's another really neat thing they developed. So those two in conjunction help keep the sphere in the water. They also, the sphere has 2 different shells, so it can also stay in one place. And while water's flowing through it, it can stay in one place and read whatever it needs to read in the water, which is important for the next point, which is it uses visible light fields to collect data and send data back and forth because wireless doesn't really work very well under the water or ground or wherever else they are. And they have no other way to really transmit data. They don't want cords or anything like that, so they use visible light. So what it does is it locates the light with the receiver, and then it keeps the outside shell in place while the rest of it is moving to keep it from going in the other direction. So it can read the data through the light because it travels very well through light. And that's about it. There's not one in use yet. It's still in development stages right now, so they don't have a cost for it, and they've never used it. But it can be completely autonomous and just basically videotape or scan the welds and then send the data back for analyzation. Any questions?
All right.